I'll bet you woke up this morning thinking, I wonder how to graph quadratic functions. Probably not, but either way, this is your special day because you're going to get to learn how to graph quadratic functions. We also call them parabolas. So this is the general form of what a quadratic function looks like. Sometimes it's written as f of x, and basically f of x stands for a function of x. And these are integers or values of some sort that can also be fractions, positive, negative, whatever. But you have an x squared term, an x term, and then some kind of constant. We often replace f of x with y, especially when we want to solve for a particular point that we're graphing for the quadratic function. So either one of these is going to be acceptable mathematically. They mean a little bit different things, but that's okay. So generally a quadratic function looks something like this. Now it can be facing up like this one, or it can be facing upside down, sort of like this quadratic function. But either one of these are quadratic functions. If you'll notice, they both have what's called a line of symmetry or an axis of symmetry. It's called, either one of those is fine. And if you'll notice, the parabola is symmetrical, the symmetry part, about this imaginary line. And so we usually draw it dashed so that we can see it, but it's not actually part of the graph of a quadratic function. The quadratic function is actually the curve here, or in this case, the curve here. The quadratic functions have either a maximum or a minimum. Like if this is facing upward like this is going to mean that this is the minimum that this function, minimum value that it can be. It's called the vertex. Or like I said, if it's shaped this way, then it would be called the maximum. It's still the vertex. Notice that the vertex always sits on the axis of symmetry. The x value right there is on the axis of symmetry, and the y value is either the minimum or the maximum. Now, we've done a lot of work where we've solved quadratic functions either by factoring or quadratic formula, and we've always said, x is equal to this, x is equal to that. Well, here is why that was important. So that root or that zero or that solution for x is where the parabola crosses the x-axis. So y is 0. That's where it crosses the x-axis. Again, same thing here. So they're called roots. Sometimes they're called solutions. They're called zeros. It basically means the same thing. There's also a part where the parabola will cross the y-axis, and so that's called the Y-Intercept. And again, because the Y-Intercept is where x is 0, like there's there's only a rise, not a run, then the Y-intercept is always going to be wherever that C value is. Because again, if you put a 0 in here and a 0 in here for X, then Y ends up being whatever C is. So there's just some vocabulary here. So there's some calculations that we'll do to find out the various parts of a quadratic graph and then graph it, okay? So it's kind of an overall view. So let's start looking at our notes. And here we go. So quadratic functions, like I said, can either be facing up or facing down. They're also called parabolas. They have this general format where actually this is going to be either y or f of x. But to solve it, you would set to find the x-intercepts. You would set it equal to 0. So again, like I said, we've used the quadratic formula or factoring, and we got values for x. And when we get those values for x, again, we call them as zeros or roots or solutions, and that's actually where it's going to cross the x-axis, and we call them x-intercepts. So then the next part, you're going to be asked to solve for a variety of things in order to graph. The first one is the axis of symmetry. Well, how do I know what it is? There's a formula right here. So if you take the axis of symmetry is going to be the line that x is equal to negative b over 2a. Now remember, the b part is right here, whatever's in front of x, and 2a means whatever the number that's in front of the x squared. So you just put it in this formula, and you graph that dashed line. It's going to be vertical if it's a function, and then you just graph it on the graph, whatever that is. And that means that that axis of symmetry, the parabola is going to be symmetrical on either side. So that means that if you have a point over here that was 1 unit to the left of the axis of symmetry, you can actually find the other point on the other side of the parabola because it'll be 1 unit to the right. That's really helpful later. The vertex, like I said, is either going to be the maximum or the minimum, and it's going to be on the axis of symmetry. So it's going to be the x value that's on the axis of symmetry. And then to find the y value, like that point for the vertex, you actually put in the value that you got for x, into the function and solve for y, and we'll do some examples. So again, like I said, the vertex is going to be on the axis of symmetry, so that's your x value, and then the y value is just going to be you plug in the x wherever x is and solve for y. The y-intercept is always going to be that c because it's where it crosses the y-axis, so x is 0, so these parts turn out to be 0, and the y-intercept is here. How do you know if there's a maximum or a minimum? Okay, so if it opens up, it's going to have a minimum. If it opens down, it's going to have a maximum. Now, how do you know if it opens up or it opens down? You look at A. You look at the number that's in front of the x squared. If this number in front of the x squared is positive, then that means it points up. And I always think of like it's positive to score a goal, like in football or something like that. Yay, you know, we scored a goal. Okay, so we kind of put our arms up. So that's positive. And then negative is going to be down, like, you know, oh, you know, we didn't score. We didn't get it. So you kind of lean down and put your arms down. So then that means it points down, and that means it would have a maximum. So I just kind of like draw these little things like, oh, it's positive, you know, I'm going to put my arms up like I scored, or it's negative, oh, I'll put my arms down like, you know, bad things happen. All right, so the minimum or maximum value, if it asks you specifically for the maximum or minimum, it only wants the y value of the vertex. So we'll get to that in just a moment. All right, so the next part is what if they ask you to find the x-intercepts? Well, you already know how to do that. You've done it before. You're going to take your quadratic function and set it equal to 0 instead of f of x or y and solve for x. You know, use the quadratic formula or factor or whatever. Now, extra points, how do you find extra points? Basically, when you plot the vertex, the x-intercept, the y-intercept, you start using the axis of symmetry to count left or right and add in those extra points to kind of get the general shape of the parabola. Domain. Domain basically says what are all the possible values or what are the limitations of all the x values of your parabola. And generally, if you're going to have a parabola that faces up or faces down, in this case, then all the x values are going to be from negative infinity all the way to positive infinity. And that's because if you look at either one of these, when I go left, left, left for x, this parabola is going to keep going up, 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 up. And so it'll go to negative infinity for x. And then for the positive part of x, if I keep picking numbers like x is 1,000, this parabola will eventually, you know, keep going up. And so the domain or the x values, whether it's pointing up or down, it's going to end up being from negative infinity to positive infinity. So it's all real numbers. Now the range, if it asks you about the range, then you have to kind of pay attention to that vertex. Now the range means what are the possible values of y. So in this case, the possible values of y is everything above the minimum. So if the minimum is, like in this case, it's -4, so y can be from -4 all the way up to positive infinity. And again, that's the value for y. We're looking for all the y values. And since it just goes up forever, that's why there's the positive infinity. If it's facing down, then this is a maximum. And so that means that y can be this number, which is 1, 2, 3, 4, 5. It's going to be, the maximum it can be is 5, and the minimum is negative infinity. And so for that case, when it faces down, you would go from negative infinity up to 5, whatever that number is. So let's do an example. We did a few in class, but let's keep going and do another one. And we'll go through all of those notes and kind of do the same thing. Okay, so the first thing it asks for is the vertex. But usually I just start with the axis of symmetry. So the axis of symmetry formula is the line that x is equal to negative b over 2a. Okay, so what is b? B is -6. And what is a? 1. Okay, so -6 becomes 6. And so that's 3. So that means this line, x is equal to 3, is my axis of symmetry. So you can plot that right away. X is equal to 3. Okay, and we usually use a dashed line. So again, this axis of symmetry means that my parabola either is going to face up or it's going to face down, but all the points on the left and points on the right are going to be symmetrical. So if you look at a, right here, the number that's in front of x squared, what do you notice about it? It's positive. So since it's positive, then I'm going to draw my, yay, I scored a goal. I pointed up, and so by looking at this, does that mean it'll have a maximum or a minimum? Well, clearly it's going to be a minimum. So it's going to be a minimum since A is positive, okay? All right, so basically it's going to look like this somehow. Okay, so the next thing we do is we start looking at X-intercepts. Or, yeah, we can do X-intercepts next. Okay, so the X-intercepts means where y is equal to 0. So you set the whole function equal to 0. X squared minus 6x plus 8 is equal to 0. And you have to solve for x. Well, in this case, I would probably, it looks like I could solve for it by factoring pretty easily. So I see that I have x and x. What times what is giving me positive 8, but when I add them, I get negative 6, so I get negative 4 and negative 2. So then I know that when I set x minus 4 equals 0 and x minus 2 is equal to 0, I get x is equal to 2 or 4. So those are my, and they'll end up being positive. So my x-intercepts are at 2, 0, and 4, 0. So, my goodness. Okay, so I go ahead and plot that on my graph, 2 and 4. So those are 2 points on my parabola. It's going to be kind of skinny down here. All right, so the y-intercept is where x is equal to 0. And so we know that if we put 0 here and 0 here, my y-intercept ends up being 8, or C. Okay, so then we can go ahead and plot that. Now here's where the axis of symmetry and the extra points come in. Because if you'll notice, this point is 1, 2, 3 units to the left, which means there must be a point 3 units to the right of the axis of symmetry because it's symmetrical that way. So we have another point of 6, 8. That's like an extra point that we have on there. Okay, so now we need to find the vertex, the other part of the vertex. Well, we know the vertex is going to lie on this axis of symmetry, so we already know the x part of the vertex. So the vertex is going to have an x and a y part, and the x we already know is 3 because it's going to fall on the graph. We just need to find y. All right, so how do we find, if x is 3, how do we find y? Well, that's pretty easy. We just put it in the formula. 3 squared minus 6 times 3 plus 8. And so y is equal to 9 minus 18 plus 8. So y is equal to negative 1. Okay, so our vertex is at 3, negative 1. So right here is our vertex. Okay, now you kind of get the idea of the shape of the graph at this point. Okay, so now we know, since we know the y value of the vertex, we know that the minimum is at negative 1 because that's our y value. All right, so let's talk about domain. If you'll notice that you can kind of imagine the shape of the graph, the domain is going to be from negative infinity all the way to positive infinity because this graph is going to end up, let's go ahead and draw. I usually draw like a smile first so that we don't have like, we don't want parabolas that look like this with a big point. We want to kind of curve it a little bit, which I didn't do very well. But anyway, you want to kind of curve it a little bit. All right, and you kind of get the general idea of how it looks. Kind of missed the point, but you get it. Okay. All right, keep going. Okay, so the domain goes from negative infinity, that's the x values, all the way to positive infinity. But y actually has a minimum. So the lowest y can be is negative 1, and the most y that this graph can be is all the way up to infinity. So that's what would give you that. Okay, so let's go ahead and put our vertex in. 3, negative 1. So if you just follow this system for H1, you'll kind of get an idea of how the graph looks. And now you can graph quadratic functions, and you know what all of these vocabulary words mean on this graph. Good luck.